And we're back. Week number 4, multiplying fractions. All right. Now, what's most important is that you understand how to simplify fractions. So let's take 18/24, for example. We've learned from our previous video on simplifying fractions that all we're going to do is divide top and bottom by the greatest common factor. And the greatest common factor that goes into 18 and 24 is 6. 18 divided by 6 is 3. 24 divided by 6 is 4. So 18/24 is most simply written or expressed as 3/4. Well, what does this have to do with multiplying fractions? Let's take a look. So let's start by taking a look at 2/3 times 4/5. How does the process of multiplying fractions take place? It's pretty simple. We're just going to multiply straight across the top and straight across the bottom. Now, what I always want to look for is if there's any simplifying that can be done. Anybody on the top looking for factors of 2 and 4 that simplify with some of the factors of 3 and 5? In this case, there aren't any. So the top value is simply going to be 2 times 4, or 8. And the bottom is going to be 3 times 5, or 15. Now before I walk away, I just want to take a look at 8/15 and say to myself, can I simplify that fraction? No. Well, then I'm good to go. 2/3 times 4/5 is 8/15. Let's try another example. So we have 16/18 times 4/5. Now, as I would begin to write 16 times 4 across the top, I'd like to take a look at this 16/18 and say, hey, you know what? I can reduce this. I can divide top and bottom by 2. And when I divide top and bottom by 2, I'm left with 8/9, which is a more simplified version of 16/18. 4/5 cannot be reduced. You say, no. Okay. And now I'm going to multiply straight across the top. 8 times 4 is 32, and 9 times 5 is 45. Are there any common factors for 32 and 45? The answer to that question is no. So 32/45 is the simplified version of 16/18 times 4/5. So the trick here is to simplify first, or simplify, then multiply. And this is my best attempt at drawing an arrow. Sorry about that. Now let's try something a little bit more complicated. 15/14 times 21/10. So the first thing we do is we look at 15/14. Can you reduce that? No. 15 and 14 don't have any factors in common. How about 21/10? Nope. No factors in common there. Okay, so let's proceed. 15 times 21 over 14 times 10. You say, wait a minute. You want me to do this without a calculator? Well, let's see something else. First, we have to go back a moment in time. Let's think about the commutative property of multiplication. A times B is the same as B times A. Or for a more specific example, 2 times 3 is equal to 3 times 2. Right? Order doesn't matter. Well, in that case, then, 15 times 21 is the same as 21 times 15. And we're going to leave 14 times 10 on the bottom. Well, now that's interesting. 21 over 14 have some factors in common, and 15 over 10 have factors in common. So what can I do with that 21 over 14? They're both divisible by 7. That's our greatest common factor there. 21 divided by 7 is 3. 14 divided by 7 is 2. As far as the 15 and the 10 are concerned, 5 is the greatest common factor for those two. 15 divided by 5 is 3. 10 divided by 5 is 2. Now we're totally simplified, and my final answer then is now going to be 3 times 3, which is 9, all over 4, and we're okay with the fact that that's a improper fraction. At the high school level, we don't worry about things like that. What we're talking about at this point is the whole concept of cross-canceling. Using this idea of cross-canceling, let's take it and let's try this problem right here. So 63/54 can be reduced. The greatest common factor that 63 and 54 both have in common is 9. So when I divide 63 by 9, I get 7. When I divide 54 by 9, I get 6. Now I'm going to come over here and I'm going to look at the 18/20. Sort of dealt with them. But the 18/20, I could divide them both by 2. Okay, so when I divide 18 by 2, I get 9. And when I divide 20 by 2, I get 10. Now, when I look independently at 7/6, that's reduced best I can. When I look at 9 over 10, that's reduced best I can. But, again, there's this concept that I can move things around, right? So 9 times 7 over 6 times 10. And now, these have 3 in common. But really, I want to be able to just look at them right here and employ this concept of cross-canceling and just say, you know what? Since I know that I can move them around, I just pretend that I did. I actually leave them in place. I divide both of them by 3. This leaves me with 3. This leaves me with 2. I look around, and now I have 7 times 3 on the top, 2 times 10 on the bottom, which leaves me with 21 over 20. And again, it's an improper fraction, but I'm not worried about it. It's a lot better than coming over here and it landing up with 63 over 60 and then saying, okay, I could divide top and bottom by 3, which leaves me with 21 over 20. If you miss that cancellation, you can always take a look at that last fraction and say, can I reduce this? Yes, and go here. If all of your cross-canceling and reducing along the way has happened properly, your final answer shouldn't need any simplifying. But always double check that final answer to see if it's possible. Let's try 2 more and then we'll stop there. Okay. 27/30 times 15/18. Well, first off, can we do any reducing here? What are our greatest common factors for 27 and 30? Well, I believe it's just going to be 3. 27 divided by 3 is going to land us at 9. 30 divided by 3 is going to land us at 10. I know that 3 was my greatest common factor because 9/10 is not reducible. So I know that 3 was the greatest factor that they had in common to simplify that. Okay, now, what about 15/18? Again, I think that 3 is going to be our best bet for a greatest common factor. 15 divided by 3 is going to land us at 5. 18 divided by 3 is going to land us at 6. And now again, if 9 and 5 were to be switched in order, is there any further simplification that could be done? Yes. 9 and 6 have common factors, and 5 and 10 have common factors. What can I reduce 9 and 6 both by? You say 3. Yes, I can factor out a 3 out of 9. 9 divided by 3 is 3. 6 divided by 3 is 2. 5 and 10 have factors in common of 5. That's the greatest common factor. When I divide 5 by 5, I get 1. When I divide 10 by 5, I get 2. Now, we're totally simplified across the top and the bottom, so 3 times 1 is 3, and 2 times 2 is 4. So apparently, 27 times 15 over 30 times 18 is 3/4. Just for the record, you could have multiplied 27 times 15 originally and gotten 405, and then multiplied 30 times 18, right, and gotten 540. Then you could have started trying to simplify this fraction to eventually land at 3/4. You will get there, but it's just so much easier when you employ the method of reducing as you go, therefore never having to pick up a calculator to get to that easily obtainable simplified answer. One more. And so what do we have? 72/64 times 24/18. Okay. First thing I do is try to reduce 72 over 64. And I know that 8 goes into both of those. When I divide 72 by 8, I get 9. And when I divide 64 by 8, I get 8. 9/8 isn't reducible, or simplifiable rather. So I know I've chosen the largest common factor right off the bat. 24/18 is definitely simplifiable. Divide top and bottom by 3. And when I divide 24 by 3, I get 8. When I divide 18 by 3, I get 6. And I notice that 8/6 is reducible, which means that 3 wasn't my greatest common factor. And you say, well, what was it? It was 6 originally. Is that a big deal? No. Just as long as you're recognizing it now that you can still reduce. It happens. All right, so what could I do? I could say that 9/8 is still my first piece, and that 4/3 should have been my second one. Or I could have chosen at this point to reduce the 9 and the 6 both by 3 and the 8s by 8. At the end of the day, it's all going to work out just the same. Let's see how it plays out. 3 and 9 can both be divided by 3. That leaves us 9 divided by 3 is 3. 3 divided by 3 is 1. 4 and 8 are both divisible by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So what am I left with on the top? 3 times 1 is 3. What am I left with on the bottom? 2 times 1 is 2. So at the end of the day, 3/2 is my final answer. Now, you go practice. Enjoy.